Good day, my amiable viewers. Welcome back to class. Indeed, the other class I told you we're talking about conjugate, acid, and bases, and some other areas. Today, we are going to start the class. Please, if you have not been subscribing to this channel, kindly do that. And again, help me to share this channel to others. Like also and subscribe. Today's topic is conjugate acid and bases. What are conjugate acid? A conjugate acid is a species formed by the receiving of a proton by a base. A base receives a proton. I told you in the other class, previous class, what a proton is. Why a conjugate base is a species formed by the loss of a proton from an acid. For example, you have HCl plus NH3. It's a reversible reaction. That is a reaction that can proceed both ways when the conditions are changed. Check my previous video. You have NH4 plus Cl minus. This is an acid and this is a base. This is a conjugate acid and this is a conjugate base. Now, this is an acid because according to definition actually given by Bronsted Lowry, we talked about that one before. Bronsted, there are two scientists that talked about the definitions. So you see this HCl to give you H plus Cl minus. This chlorine has taken the single electron that hydrogen has. Remember, hydrogen has only one electron, but the atomic number is whether it lost electron or not. So it has taken the single electron, and so this one is left with nothing, so it becomes a proton. So this proton is transferred to this ammonium. This ammonium transferred to it, and so you now have NH4 plus. Those of you that are conversant with coordinate covalent bond, you know what I mean. It carries the hydrogen with its charge. So this is a conjugate acid. Conjugate acid this time around, instead of being a base, because it's capable of also releasing a proton. This one releases the proton, so it's an acid. This one is now capable of releasing a proton, and this is capable of accepting the proton. Because this one accepts the proton, now become conjugate base, the chloride ion. So there are also another example we can give. H2O plus HCl will give you H3O plus Cl minus. There are 1,001 examples, so we are going to limit around to just these two. You can see this water and this HCl. HCl is capable of releasing this proton to this water. Some people will say, how can you say what this is an acid? This is a base. Some people will say, how can you say the water is a base? According to Bronsted definition, in as much as it can accept the proton, automatically can be referred to, and remember I said referred to as a base. So it takes the hydrogen ion and receives it, now become hydronium ion. Or hydrozonium ion, both of them are correct. So this one is now capable of receiving a proton from this hydronium ion, making this one conjugate base. This is conjugate acid. So that is how it is. The species that can receive a proton referred to as base. In this side, the left hand side, this is a base and this is an acid. While on the right hand side, this one becomes the acid, this one becomes the base. So that is that for conjugate acid and base. Then let us also talk about dilute solutions and concentrated solutions. My friend, please do me a favor by kindly helping me to, you have been helping me to share this video. Please do more and God will continue to bless you. You have a dilute solution. Concentrated solutions. What are dilute solutions of acid and base? Dilute solutions of acid and base, as the name implies, are dilute. It contains larger amount of water. Dilute solutions, a simple way of representing it, more water, little acid. Solutions. That's for dilute. More water, little acid. Remember, you don't pour acid to water. You always add, you don't add water to acid, you always add acid to water. This is concentrated solutions. The key word: more acid or base, less water, little water. Don't ever forget, when we talk about dilute solutions, we're talking about more water, little acid. Then concentrated solution, more acid, little water. Most of the solutions we buy directly from those that sells them, usually in concentrated form. The chemistry teacher in your school or wherever you are will now prepare it and make it dilute solutions. Like what solutions you use for titration, they are usually dilute solution. That's why they are actually not harmful, but don't drink it, they are not edible. So this is where we stop the class for today. Please remember, dilute solutions contain large amount of water and little amount of acid. Remember, you don't pour water to acid, you pour acid to water. You continue to increase the concentration gradually. Then concentrated solution contains more acid and very little amount of water. Thank you for watching my video. Please subscribe if you have not been doing so. Like, press the like buttons and also share. God continue to bless you. Thank you.